Okay, for this example, I want to create a, not so trivial example um, that really illustrates the need for promises. So take as requirements. Consider that you are trying to build a very simple templating engine. All right, in this templating engine, we envision laying out our pages in a fixed way. So this is a web page. We're going to envision having a top part called the banner, a left part called the left nav. You see this commonly. A bottom part called the footer, and an intermediate or main viewing content viewing page. You see a lot of content websites driven like this. I mean, even Blackboard tends to look like this, right? Um, so we're envisioning building a site like this, and then we want to fill in different fragments of content to each one of these places. Okay, so that's the gist of what we're trying to build. And we're going to motivate that as a use case to use promises. Okay, this is actually what it looks like on the browser. So I already have this. Didn't want to do that. I wanted to do that. Just zoom it out for you. So this is exactly what I just drew for you, right? A banner, a left nav, a footer, and a main. So the way this is done in an HTML template, okay, if you look at the HTML template that I catted out to the screen here, it's a simple table with the middle row of 3 rows split between the left nav and the main, with the left nav taking 20% of the real estate and the main taking 80%. Okay, now what we need to do though is to fill in different content. So when you look in the HTML subdirectory, we have a bunch of sample files that are intended to be used as different banners, different footers, different lefts, and different mains, right? Anywhere from 1 to 4 of them. So we want to build a node application that will um, display different combinations of these based on what the query string is. So we have one built here called, that's using the template version of doing something, callbacks.js. Okay, so given an idea how this works, let's go to our browser and access the callback version of this running on port 8088. And really we're going to give it a query string that indicates a number for each one of the components of the each one of the components of the template that we were seeing before. So this gives you an example. Here's the banner part. It's been filled in with whatever's in banner1.html. Why? Because banner equals 1. What it basically did was a text substitution or for what's in the table at this part in this table layout. The same thing for the other components based on the name plus the number.html, and all that is underneath your subdirectory. The HTML subdirectory in the sample code. So the main2.html contains this example. That was our HTML5 example. The left 1 example has this navigation menu, and the footer2 is equal to that one. I could change any of these parameters around. I could change the footer to 1. I could change the content here as long as I have a valid file with that one. Right now I changed what the banner looked what the footer was, and the footer what the banner was, because I'm using the same thing. The same file is just renamed for footer and banner. Here's a different menu over to the left, and here's different content in here. I mean, this is just HTML fragments I grabbed from wherever. So again, I can mix and match and do these different variations any way I want. And get different content mixed in here based on what the files are. So very simple templating approach. I could even go in and move things around. Let's take a look at the template file here. In fact, you look at the HTML directory, you see all these files in here. This is controlled by the template file. I could even take and modify the left nav and put it on the right without restarting my server. I just resave the file. I go back to my browser, and if I do a reload on this, now the nav is over to the left as opposed to being on the right. Simple things like that. I'm going to put it back where it belongs, because if it's a left nav, it belongs on the left. Okay, let's take a look at the code here. And really what I have on the left is what I'm running. So let's look at this one first. In fact, let's just expand to the full screen. This is the template callbacks JavaScript file. This is the one I'm running right now. This one, now, I mean, think of what it takes, even before running through the code, think of what it would take to put this kind of go from here to here. All we're doing is bringing in different fragments and text substituting them. So literally grabbing the string banner, grabbing the string laugh nav, and substituting in the contents of a file. But in order to do that, I basically have 5 asynchronous file reads to stack up. I've got to read in the template file itself what you're looking at in front of you, and then for each substitution I'm doing, I'm going to read in a file corresponding to, again, I know I'm jumping around here, according to one of these. I have 2 banners in here, 2 footers, 4 left navs, and 4 mains. So again, I can use parameters 1, 2, and 1 through 4 for left and main. And I'm just substituting whatever's in those files and slamming those into the template at that part. So fairly straightforward program, but you can see the problem. I'm going to basically have to read in 5 files in a chained order. The entire template, the banner, the left nav, the main, the footer, whatever order those go in actually doesn't matter. But as I go along, I'm going to be text substituting in the string that I'm building to be the output. That, again, will wind up looking something like this, depending on what those parameters were. So, again, if I want to do it in the traditional way, I'm going to have a stacked sense of, and you can see a stacked version of each one of these. I'm going to be reading a file. In this case, I have the callback with the error. I want to catch errors, right? If I catch a template, I'm doing a 500 error and writing that out. Otherwise, I want to go forward. If I go forward, that means I'm going to take the string version of what was read out of the template file and then read another file. All right, I'm going to do the same thing over and over here. I'm going to check for an error. If I have a problem with here, it's probably a query parameter, so I return to 400. If I'm successful, then I'm going to string replace banner with the banners with the one I did first. All right, if you notice, this kind of looks like some of the stuff you did in the server static file. That's the one I started with, in fact, and so forth. Next, I'm going to do the footer, and I'm going to go down with the footer, and I'm going to do a replace of the footer, and so on. Then there's the left nav, and then finally the main, and then when I get done with each of those, I can finally output the output if I got all the way through with no errors. So there's a few things. One is clearly a case. You can see the indentation of our callback hell. Each one of these is chained because the previous read file is going to have a callback, all right, that indicates the next thing to do. Also notice in the callback, our application logic is very hardwired into a specific callback, meaning I can't cut and paste and move these things around like modules because they're somewhat dependent on the ordering of each other. I also have redundant and distributed logic around error handling, right? Each one of these has an if error block that essentially does much the same thing. So I have this repeated pattern indented over and over, but it's all the way out to 74 lines of code just to get that thing done in the same over and over way. Trying to make this more readable, trying to isolate things where they belong, like error handling in the individual sequence parts. This is a really good case for promises. From a promise perspective, we want to say, hey, let's read in the template file, then when that's successful, read in the banner, when that's successful, read in the footer, when that's successful, read in the left nav, when that's successful, read in the main. Now again, promises are really just syntactic sugar in a sense, because that is what this nested callback sequence does. But again, very, very tricky to look at and to read and to find the callback for what you want to do. You kind of got to look up in the file like we were saying before. So let's bring up the promise version of it side by side. The promise version of it, I factored out that common logic, the read file, so that the read file will take in the building output that we're doing, the file that we want to read at the time, and the string we want to replace, and goes ahead and creates a function that returns a promise, right? The first line you see here is a return with a new promise, and then it gets into what the resolve and rejects are here. And that's where we're wrapping the read file, right? We're doing the read file of the file we're passing in. It still constructs the file with the request parameters in the same way down there, and the callback for this one. If we have an error, then the promise wants to be rejected, if you will, and we want to indicate that kind of redundant error handling, right? It's all right here just in this one reject line now. Otherwise, we're going to handle the two cases. We're going to handle the case where the replace string doesn't exist, and that's how we read it in the template, because we're not doing any string replacements when we first read in the template. It's after we read in the other files. And also using a resolve in the case where we do have a replace string, because that way we can go ahead and do the replacement using the string replacement structure on the output that was gotten from the file. All right. Now I can, the real thing is now I'm back to rendering, all right, doing a set of read file and replace wrapper functions. I did that return a promise and being able to chain them, because when they're called, they call yet another, they generate yet another promise, which means I can chain them together and I can look for the result. Here's an example where actually, before I use the arrow syntax on the resolve in the previous example that we did in the lecture slide, the lecture presentation, because I wasn't returning anything. Here I'm not using the arrow syntax, and here I am returning something. As you can see, I'm returning an object literal. In the resolve, that object literal is going to have my status code and the output I want to produce. So I kind of wrapped I had to have a single result, so it had to be an object there in order to do that. So I chain these things together and I give them different files that I'm reading in and different strings that I'm going to substitute, and then I can go through them one at a time. In this case, I'm doing banner, then the left, then the footer, then the main, till I get to the final result of doing the main, and I can go ahead and write the content out in that positive case. Here's an alternate syntax as well for handling the error. This is the catch part that we saw in the previous example. Here, this is the syntax of a comma. Here is very important, because this tells me, remember, resolve reject. So this is telling me what the reject version is. In the reject version, I'm going to return something as well. I return object literal, same format. I just call it the error object. And actually, here I have error the output. What I really should have here is error dot status rather than hardwiring it. Even though I want to do the same thing, because I returned that object and can access what the status message and the output was in that case. Okay, that being done and saved, I'm going to go stop the previous version and run, even though it's functionally equivalent. I'm going to run the promise version. All right, that's running. Go back to my browser window, and everything's going to look transparent. So even though, well, remember, I switched the template back too. So let's do left nav 1. Let's change the banner to be the same, and boom, there you go. Functionally, there's no difference than we had before, but look at the difference in code. Here I have a promise version with 45 lines of code, and here I have an asynchronous nested callback, almost twice as long, 75 lines, all that indentation, all of trying to find these callbacks in the midst of the line wrap and everything else. I'm sure I probably could have factored and cleaned it up a little bit by trying to create a function like this, but not quite as easy to do as compared to this example. This block is what the real winner is. This block compared to the chain set of indented asynchronous callbacks is what makes promises biggest winner. Functionally equivalent, really underneath the hood, frankly, they're really doing the same thing. And again, we haven't explored more ambitious uses of promises, but really that synchronous flow, the readability of the code is what our advantage is.